In this video, we are going to talk about the top 10 origins of the universe. So before starting, please like this video and subscribe to this channel for future updates. One of the most amazing things a person can say is that 13.77 billion years ago, the entire observable universe fit inside of a peach and was over a quadrillion degrees hotter than the sun. The fact that this story, the Big Bang, is supported by a century's worth of diverse, independent lines of evidence makes it all the more amazing. A great history of our cosmos is derived from this fundamental foundation. Yet there are still many mysteries to be answered. The Big Bang is at the heart of the most well-researched theory of the birth of our universe. This theory was developed in response to the discovery that galaxies outside of our own are traveling very quickly in every direction, as if they had all been propelled by a powerful explosive force in the distant past. Here are the top 10 origins of the universe. Number 10. Cosmic ego trip. The strength of gravity, electromagnetism, and subatomic forces is determined by a small number of fundamental constants that are part of the rules of physics. These numbers might, as far as we know, have any value, but if they differed even slightly from the values they currently have, the universe would look quite different. The most significant aspect for us is that life as we know it is impossible, including, of course, our existence. According to the so-called self-centered anthropic theory put out by Nick Bostrom in his book Anthropic Bias, some people view this as proof that the cosmos was purposefully created in order for life that resembles humans to evolve. It's critical to keep in mind that the cosmos is vast and that our life is but a minute blip in the scheme of things. Number 9. Could some aliens use us as a test subject? Popular in science fiction, the idea that humans or life on Earth could be an experiment or observation by alien beings has been put out as a potential explanation for various inexplicable phenomena or odd happenings. Whilst many scientists believe it is implausible, there is yet no hard evidence to back up this theory. We simply don't have enough data to determine for sure if there are any other sentient life forms in the universe, while it is undoubtedly feasible. The prospect of taking part in an alien experiment or observation also begs numerous moral and philosophical queries concerning the origins of life and consciousness, as well as our interactions with other species throughout the cosmos. It is best to approach such notions with a healthy dose of skepticism and open-minded curiosity until we have more conclusive data. Number 8. Simulation theory. The simulation theory postulates that a highly developed society constructed our cosmos as a computer simulation. This idea holds that the physical world we see around us is essentially a virtual reality, just like the world in a video game. In recent years, especially in the areas of theoretical physics and computer science, the concept of simulation theory has drawn more and more attention from philosophers, scientists, and authors of science fiction. The belief that as computer technology develops, it is inevitable that we will one day be able to create highly complex virtual environments that are indistinguishable from the actual world is one of the fundamental justifications for simulation theory. If so, it's possible that we're all living inside of a simulation that was already made by a highly developed society somewhere in the universe. The simulation theory, however, is still only a theory at this point and has no hard data to back it up. The concept also prompts a host of philosophical and moral queries concerning the nature of reality and the reason for our existence. It is crucial to approach simulation theory with a healthy dosage of skepticism and to keep investigating the secrets of the cosmos through scientific investigation and observation, even though it is undoubtedly an intriguing subject to think about. Number 7. Superfluid SpaceTime. We can imagine the world existing in four-dimensional spacetime even if space only has 3 dimensions, since there is still a 4th dimension in the form of time. Other hypotheses state that this is a physical substance in and of itself, comparable to an ocean of water, as stated by Stefano Liberati of the International School for Advanced Studies and Luca Maction of Ludwig Maximilian University in their article published in the Physics Review Letters journal. According to this idea, spacetime is composed of minuscule particles on a more fundamental level of reality than our instruments can access, much like water is composed of innumerable molecules. According to the theory, spacetime is represented as a superfluid with no viscosity. Such fluids have the peculiar habit of not rotating completely, as happens when you mix an ordinary liquid. Little vortices are created as they split apart, and in the scenario of superfluid spacetime, these vortices may represent the origin of galaxies. Number 6. We got gravity wrong. Gravity is the only physical force that has an impact on matter on a very large scale, therefore theories of the universe depend on having a precise knowledge of it. But gravity alone can't explain some astronomical observations. Stars on a galaxy's periphery are moving too quickly to stay in orbit if the only thing preventing them is the gravitational pull of the visible galaxy, according to measurements of their speeds. Similar to galaxies, clusters of galaxies seem to be bound together by a force greater than that explained by the gravitational pull of visible stuff. There are two potential answers. The prevalent theory holds that the universe contains invisible dark matter that fills in the gap left by gravity. Number 5. A star is born. The atoms gradually coalesced into clumps of atoms by congealing together. More atoms were drawn to the party as those clumps grew larger, which accelerated their growth by exerting a stronger gravitational pull on the area around them. Some of those clumps got dense enough to start nuclear fusion in their cores over the period of 100 million years. You'll notice that finally our timescales are becoming appropriately astronomical. The first stars appear. These stars would start the process of forming the components required for life by churning elemental hydrogen and helium into heavier elements. Number 4. The Big Splat. Galaxies will eventually drift apart to the point where light from one galaxy can never reach another in the long future. In reality, there will eventually be no light or heat when stars ages and dies. The universe will be an ominous, icy, and barren emptiness. One idea claims that while it may seem like everything is coming to an end, it actually marks the start of a new universe in a cycle that will never stop. Recall the Brainworld hypothesis? This is what occurs when two cold, empty brains meet, which they will eventually do given enough time. Such a collision, according to cosmologists Neil Turok and Paul Steinhardt, would produce enough energy to create an entirely new universe. Although physicist Michio Kaku has more evocatively named it the Big Splat, they refer to this as the ekpyrotic theory. Number 3. Brainworld. An aspect of the universe we take for granted is that it's three-dimensional. There are 3 perpendicular directions you can move in. Some theories, however, suggest another spatial dimension, which we can't perceive directly, in another perpendicular direction. This higher dimensional space is referred to as the bulk, while our universe is a 3-dimensional membrane, or brain, floating inside the bulk. As complicated as it sounds, the Brainworld picture solves several problems in physics. For example, theoretical physicists Lisa Randall, of Harvard University, and Raman Sundram, of the University of Maryland, proposed a version of the Brainworld that explains an asymmetry in subatomic forces by suggesting the existence of other brains parallel to our own. Number 2. Things got really big, really fast. Our universe expanded extremely quickly when it was only 10 to 36 seconds old. The cosmos expanded alarmingly quickly during an event known as inflation, increasing in size by at least 60 orders of magnitude in less than 10 to 32 seconds. And no, I didn't pick arbitrary numbers to use as the exponents in the statements above. Even though we lack direct observations of this significant life-changing event, there is a substantial amount of circumstantial evidence to suggest that something similar took place in the dark and distant past of our universe. Number 1. In what way will the cosmos end? Scientists now think that the Big Bang was the beginning of the universe. However, how will it end? Theorists come to the conclusion that the universe's future could take one of numerous wildly different forms based on a number of various elements. The entire universe could condense into a single point, a mirror image of the Great Bang known as the Big Crunch, if the amount of dark energy is insufficient to withstand the gravitational pull's compressive force. Yet according to recent research, a Big Crunch is less plausible than a Big Freeze, in which dark energy drives the cosmos into a long, steady expansion until all that is left are dead planets and burned-out stars that are just over absolute zero in temperature. What do you think about our video? Let us know in the comment box below. Please like this video and subscribe to this channel for our future updates. Thank you.